So you can solve two-step equations by applying some algebraic properties, and this video, this note session is to talk about the steps specifically. I kind of covered up steps. There it is. We'll color that blue right now. There we go. Steps. Great. All right. So what are the steps? The first step you're going to love. You're going to be like, I've never seen such an amazing step. Write it down. Oh my gosh, such a great step. Here's why I mention that. Some students write down the problem wrong. I write down the problem wrong. People write down the problem wrong. And then they do the math correctly. So just make sure and write it down correctly, right? Step 2, you're going to simplify this. And if you're like, what do you mean simplify? Well, to go from here to here, they followed PEMDAS, or maybe you're more familiar with GEMDAS, or maybe you have something else. I don't know. But the idea is that you are working through these things that are done in math. You start here, you go this direction when you are simplifying. So why do you do that? Well, because you might have parentheses or brackets or something like that. You might have an exponent, which is what the E is. You might be multiplying, you might be dividing, adding, or subtracting. You need to know which is done first. You're technically always asking, can something be simplified? And on this particular problem, yeah, we can simplify 2x minus 9x. It can become negative 7x. So that's why the next step is you should simplify things. Get it ready to be solved. Speaking of solving, once you have gone through simplifying, you are now down here. You are now ready to solve, okay? And when you solve, you actually go this direction, okay? And in fact, I don't know what that means. Well, okay, we're ready to solve, and you then ask, hey, can I, let me change colors here, can I add or subtract to get x by itself? Can I multiply or divide to get x by itself? And I'm going to go ahead and give you a spoiler alert. We're not going to super duper need these two right now because we're just not going to need them for a long time. So back over here, the question is, okay, now that we have 7x equals 28, there's nothing to simplify, so we're ready to solve. So is there any adding or subtracting happening to our problem? Is there any adding or subtracting happening to x? And the answer is no. The only thing that's happening is it's being multiplied. So when you solve, you do the opposite. And if you're like, okay, how am I supposed to remember this? Here's how I think of it. You first learned about the world and everything was normal and right side up, and then Stranger Things came along. Yes, the Netflix show. And then what happened is you went to the upside down, okay? You learned about the upside down. It's not a real place, not a real thing, but it's still fun to think about. And in the upside down, things were fairly opposite, okay? If you're going to solve, you got to do the opposite because that's in the upside down. Okay, great. So there was no adding or subtracting, but there is multiplying. So what's the opposite of multiplying? You said it. It's dividing. So we will divide by negative 7. And you might be wondering why there's a little orange or red and gray box here. Well, here in a second, there won't be if I can figure out how to delete it. Come on now. Boom, boom. It is having me select everything. Here we go. Ready? Now it's gone. So check it out. They divided by negative 7 on both sides. So guess what the blank is? Divide on both sides. Now, this divide part right here could be multiply, could be add, could be subtract, right? As long as you do it to both sides, then you are keeping up the equal business. Things need to be equal, okay? And then, here's the goofy part. The next thing is simplify again, because you want to simplify this to actually be your answer of negative 4. Hooray! These are the formal steps, so to speak, of how to do this. You write it down. I know that seems silly. In fact, I wouldn't even call it a formal step. It's more of an informal step. But you need to think about whether you need to simplify. Then what you're going to do to both sides, and then to simplify again. This is how you solve anything. In fact, I'm not going to do this example down here. I'm instead going to go to spin the wheel, which is going to be a little unfortunate for you watching the video because you're not going to spin the wheel. I'm just going to do it. But anyway, maybe I'll record it and show you that I spun the wheel. Anyway, let's check this first. If you're like, what do you mean check? Well, I mean, is this the right answer? Like, yes, it is, but is it? Maybe you, when you do this, will not know if you got the right answer or not. We'll check this out. What I'm going to do is I'm going to rewrite this. I'm rewriting it, okay? Notice what is missing. The x's, right? But it's because now I know x is 4. So I can put a 4 there and a 4 there. And I can simplify. 2 times 4 is 8. Negative 9 times 4 is 36. Oops, it's negative 4. Oops. Let's put that negative there. That's negative. That's negative. So then this would be positive, right? And here's what's funny about that. If I actually got that x was 4, I just proved that, no, that's not the right answer. But if it's negative 4, then guess what? Does negative 8 plus 36, what does that equal? Guess what? It equals 28. Does 28 equal 28? Yeah, it does. So we were right. So this was like the info that we talked about as like a last ditch. Hey, you're about to go on Thanksgiving break. Don't forget all this stuff. And we even talked about it when you came back from Thanksgiving break to say, hey, do you remember this stuff? Okay. Let's spin the wheel. Oh, it actually has sound. And we land on. Okay, so we spun the wheel. And the reason that we did that was just so that we could try, one that was a little slightly more entertaining than just writing them down at random. So here we go. Let's try this. I know we skipped this, but it is very similar to this one, and so I just wanted to move on. Here we go. So negative z over 5 minus 6 equals 1. Well, hang on. First, there's 2 sides to this, right? Second, now we technically are going to go up here and ask and think through these questions. Think through those steps. So 1, we've written it down correctly, okay? 2, can I simplify it? Well, is there any, let's actually go up here. Is there any parentheses? No. Exponents? No. Multiplying? No. Is there division? Yeah, there is division, but guess what? You can't divide this. I don't know what z is yet, so I can't divide it yet. There's no addition. There is subtraction, but guess what? I cannot subtract the 6 yet. I don't know what z is in order to subtract the 6. So guess what? We started to simplify. We started here. We went all the way down, and now we're We're going to solve now. We're ready to solve. We're going to solve by doing the opposite. The first question is then, is there any addition or subtraction? And the answer is yeah. There is addition and subtraction right here, minus 6. So we are going to do the opposite of that. Why are we doing the opposite? Because we want to get z alone or by itself. Remember, this is the puppy on the seesaw. Here's the puppy, and here's the weights. I know, awesome pictures. Great, let's move on. So we add 6 to both sides. The 6's cancel, leaving us with negative z over 5 equals 7. We are now going to multiply both sides by negative 5. Why are we multiplying by negative 5? What's happening to z? It's being divided by a 5. And then also there's that negative. We want to get rid of it. So we're going to do 2 things at once. Multiplying by negative 5. So negative 5 times negative z over 5. the negative 5s and the negatives, and the 5s and the, okay, they cancel. Leaving us with z equals negative 35. Let's spin again, here we go. Okay, wanted to do one more, so there we go. 6p plus 22. 6p plus 22 equals 4. Is that it? That's it. I know it seems silly that I would double check something like that, but I'm telling you, it's crazy. Write it down is very important. Can we simplify? In fact, I would like for you to pause the video and see, can you solve this right now? So pause it. Okay, here we go. We cannot simplify this. These cannot be multiplied together because we don't know what p is. These can't be added because we don't know what p is. Over here is simplified. So we are ready to solve. Is there any adding or subtracting happening to p? Yes. Adding by 22. So we will subtract 22 from both sides, and we get 6p equals negative 18. Now we will divide by 6. Why are we dividing? Because 6 is multiplying p. And now we have p equals negative 3. So this is how I began the day for everyone coming back from Thanksgiving break, and it's also how we ended the week for Thanksgiving, because I wanted to see if you know what the heck we're doing. So really, when it comes to these problems, I ended up doing many of them in class, but want you to finish them, okay? So what I'm going to do is I'll do some of them, but I want you to finish them. And if you're like, oh, I don't know how to do all these, what I'd like for you to do is pause this and try them on your own first, and then come back and check yourself. You won't be able to check all of them because I'm not going to do all of them. For example, I really do not want to do number 1, given that this one is much harder than that one. But I gotta hope that you know what you're doing. Maybe you don't know what you're doing. I'm gonna go ahead and do it, okay? Because of how easy it is, all right? It is literally a one-step equation. So here we go. What we've got is we have two sides of the equation. We got this side, we got this side, all right? And on this blue side, it's simplified. On this red side, it's simplified. How do I know that? Because I can't add m and 12, okay? So what I'm going to do is I'm ready to solve, and I'm going to subtract 12. Why am I subtracting 12? Because I have officially got an m by itself. That's how I will know what m is equal to, okay? It's by itself because positive 12 and negative 12 equals 0. If you got $12, you spend $12, you got no dollars left, right? Right. So m must equal negative 2. How do I know that? Because 10 minus 12 is negative 2. Hopefully you see that, oh yeah, out of 5 stars of difficulty, this one is a 1 star. Super easy, okay? Which is why I'm not going to do number 2. I am going to do number 4. I'm not going to do 3 because you just watched a video where, hey, this is what you had. They were multiplying, and what did you need to do? It literally walks you through it step by step. But number 4, maybe you go, oh, well, that's not quite step by step. It a little bit is, because we did this one. That was harder than that one. But again, I'm just going to be nice, and let's see this. All right, A is being divided by 9. I can't write my 9s like that. Anyway, so what are you going to do? Well, it's already simplified. So to get it, we want to get A by itself. We're going to multiply by 9 on both sides. So these 9s will cancel, because what's 9 divided by 9? It's 1. If you didn't know that, think about it this way. If you have $9 and 9 friends, it looks like every friend is getting $1, right? That's right. So we're left with A equals negative 36. Again, when it comes to the difficulty rating of this, 1, 2, 3, 4, hopefully you're like, okay, that's like a star and then maybe a slash. That's not too hard, right? Now, here is where I'll do a couple, because you might have forgotten that when it comes to fractions, we're going to multiply by the reciprocal. What the heck is that? Well, let me give you some examples. If I had 1/3, or if I had 2/3, the reciprocal is going to be like this, 3/2. Notice how this thing just flipped. And I shouldn't have written 1/3 first, because if you were to write the reciprocal of 1/3, it's 3/1, which we just call that just regular old 3 is what we call that. And now here's the thing that I enjoy about reciprocals. If you started with 3/2, guess what? You could also go backwards, and now the reciprocal is 2/3. If you started with regular old 3, you get the reciprocal as 1/3, okay? So if you're like, okay, I'm not really sure what multiplying by the reciprocal means, well, check this out. We have 2/3 times x. Didn't we just do a thing where if you're multiplying, you should divide? And the answer is yeah, but. So here's why I want to say yeah, but, okay? If I were to do 10 divided by 2/3, well, first of all, I'm going to go ahead and write 10. Do you know why I'm writing 10? Because when you divide by fractions, what happens is you actually are going to multiply. You're never going to guess the next word I'm going to say. You're going to multiply by the reciprocal. That's what happens when you divide. Anytime you divide, you're multiplying by the reciprocal. So if you want to write divide by 2/3, be my guest. But what you will end up doing is multiplying by the reciprocal. So just go for it now. These will cancel, leaving you with x. And now over here, you might be a little concerned. I shouldn't have written that, because erasing on this thing's kind of a booger. Let me erase real quick and put my parentheses back. Okay. You might be a little concerned about that, but check this out. 10/1, because any number can be written over 1. Any number can be written over 1 times 3/2. Well, you just multiply straight across, and you get 30/2. That means x is really 15, okay? You don't need to freak out about the fractions. You can handle the fractions, okay? I think I did number 7 for a lot of people. Maybe, you know what? I think I'd like to do 6 instead. Let's do 6. So we are multiplying. Okay, well, that means we should divide. Or wait a second, it's a fraction. Let's multiply by the reciprocal. Okay, so 9 and 4 cancel, leaving us with w. And now here's why I wanted to do this one, because we can cancel diagonally. And if you're like, what do you mean cancel diagonally? You could go ahead and multiply and get negative 72/4. You could. Or check this out. You could be like, hey, 4 can divide 8 twice. And there would be 1 left over. If we were to divide that by 4 and that by 4, it would be 2 and 1. And so check it out. You would end up getting 2 times 9 is 18. And 1 times 1 is 1. And then don't forget your negative. So W really equals negative 18. These two-step equations, super duper easy. We did a couple right here. And if you're like, they're not super duper easy to me, that's okay. Just remember that technically we're thinking through PEMDAS. We're going this direction when we simplify, and we're going this direction when we solve. And remember, you solve by doing the opposite, right? So let's take a look at this. We have the left side and we have the right side. I'm zoomed out because I want to see all this and this at the same time. So can I actually multiply 6 and x? No. Can I actually add that 8 to that? No. I have just gone all the way through simplifying, and I am now ready to solve. I put the star there because this is where I'm at now. So is there any adding or subtracting happening to our x? Yeah, there is adding 8. So here's what we're going to do. We're going to subtract 8 from both sides because that's the opposite. Okay? So what we get is 6x drops down. 8 minus 8 is 0. Okay? And 50 minus 8 is 42. What's happening to x now? It's being multiplied. So there's no adding or subtracting happening to it. But guess what? There is multiplying or dividing happening to it, right? So that's why we're going to divide by 6. Why divide? Because that was multiplying, right? The opposite of multiplying is dividing. And what happens is the 6's cancel, giving us x equals 7. That's it. Two-step equation. You can do these. On the back of this page, there are more two-step equations, like 13, for example. There's both sides of the equation, right? What's happening is we can't simplify this anymore, so we're ready to solve. We're going to do adding and subtracting first, and we get x over 2, because these cancel, equals 16. Oh no, what's happening to x? It's being divided. What's the opposite of that? Multiplying by 2. The 2's cancel, leaving me with x equals 32. You can do that, okay? 13, 14, you can do that. And if you're like, oh no, but look at 15 through 18, you're going to multiply by the reciprocal, okay? Because check it out. You hopefully pretty quickly see that we can't simplify that, right? So if you can't simplify, then you're ready to solve. And you see that you should deal with the adding or subtracting first, right? So that's gone, leaving us with 3/5 x equals 6. Oh no, 3/5 times x? Should we divide by 3/5? You can, but just remember that dividing by a fraction is the same as multiplying by the reciprocal, okay? So 5/3 cancels, leaving us with x equals, and then if you want to, just multiply straight across. 6 over 1. 6 times 5 is 30. 1 times 3 is 3. Maybe you saw right away that it was 10. Maybe you didn't. Anyway, now you got it. So, now we're to the part that this is what's new. Nothing has been new up to this point. Kind of crazy, right? But there's a new, like, hey, well, okay, this is new, and it says, watch out, because it changes the steps, sort of, okay? It changes the steps because remember how I said that we wouldn't really be concerning ourselves with parentheses? I was like, yeah, we're definitely going to deal with that. We're definitely going to deal with those. Well, now we're kind of concerning ourselves with parentheses, and here's why. It is because this is a fraction, right? And in that fraction, there's a top group and a bottom group, okay? And what's going to happen is we will technically need to deal with the groups first, the parentheses first. So if you want to, you can think of it as like there's parentheses around that, okay? So I'm going to erase all this so that it's a little bit cleaner, but here we go. if they're going to read it to you in plain English, here's what they're going to say. Here's what you're going to do. The examples below are different in that the multiplication and division is done first, followed by the addition and subtraction. And why is that? Because of this, because of the groups, because of the parentheses. So check it out. You were looking at this going, there's a left side and a right side. I can't add 11 to that, and I can't really divide by 8. So here's what I'm going to do. I'm going to deal with the 8 first. So if you were looking at, okay, can I simplify? Well, remember, simplifying goes this direction, and the answer is no, we cannot simplify. But remember, now we're down here. We're ready to solve by doing the opposite, right? So, can I actually deal with the 11? I would love to subtract the 11. But how are you going to get it out of that top without messing with that 8? You're not. So, you can move on down the line and realize, hey, wait. In one of the groups, it's dividing by 8. So what's the opposite of dividing by 8? It's multiplying by 8. So that's what we're going to do. And the 8's now cancel, leaving us with x plus 11 equals negative 24. And now this is like, if this is all I've got, I subtract 11 on both sides, and the 11's cancel, leaving me with x equals negative 35. I'm done. That's it? Yes, that's it. Want to see another one? Great. I'm glad you said yes. Let's do 21. 21. On the left side, that's simplified. We don't need to talk about it. On the right side, that's simplified. We can't do anything with that either. And if you're like, yeah, I can divide that by 6. You can divide that little piece by 6. But you would be left like this. So let me just show you one of the other reasons why we don't really want to mess with the subtraction first or the adding first. Because if you truly divided by 6, this is what you would get. A divided by negative 6 is A divided by negative 6. No change there, right? Negative 13 divided by negative 6 is plus 13 sixths. Okay, so yeah, technically speaking, this does equal 1 because of that 1. So here, just because I'm crazy, I'll side by side these to let you know you could do this, but why would you do that? Why would you want to? Instead, I would rather go, you know what? This whole thing is being divided by negative 6. Why don't I multiply by negative 6? And so what happens is the negative 6's cancel, leaving me with negative 6. If you're like, didn't I cancel? We multiplied them over here. Negative 6 times 1 is negative 6. Equals A minus 13. This guy got left behind. Okay, and now we can just say, oh, look, I'll add 13. I add 13, and I get, the 13's canceling, I get A equals 7. A is 7. And you're like, wait, I thought you said you were going to do it side by side. Yeah, here we go. So I divided them individually. So now I can go, hey, you know what? I can subtract 13 sixths. Subtract 13 sixths. And what I get is these cancel. And now 1, this 1 right here, it's just easier to make it 6 sixths. And so 6 sixths minus 13 sixths is negative 7 sixths equals A over negative 6. We having fun yet? I am. I sure am. So I didn't do my little line making them 2 separate problems. Hey, here's a reason why you do that, by the way. All right, next, A is being divided by negative 6. So I will multiply both sides by negative 6. And what happens is these 6's cancel, and these 6's cancel, right? But check it out. There's this negative right here, and this negative right here, and A ends up equaling positive 7. Got to be honest with you. I wasn't intentionally trying to sell this as the uglier, dumber, worse way of doing it, but I don't like doing this. I didn't like doing that. I didn't love doing that. That was kind of annoying because the fact that they were both 6s, but one's a negative and one's a positive was kind of annoying. Coincidental, but annoying nonetheless. So if you're like, oh my gosh, I'm so confused, then go back and rewatch just me doing this part of the video where I multiplied by -6 on both sides, and I got this yellow part. I added my 13 on both sides, and I got 7, and I was done. Okay, so your assignment is to finish this one, and these 2, and these 3, and these 4, and these 2. You notice there's something over here. That'll be coming up later. Hopefully you are officially welcomed back into solving equations. Let me know what questions you got. See ya.